screw consumers. And today I present to you, not proudly, Inevitable Opportunity to Screw Consumers. In that piece, we showed that, for the first time this year, GPU prices had finally hit a downward trend for consumers. This was just as the DRAM shortage ramped to hit consumers the hardest. GPU MSRP is still elevated above what's reasonable overall, but cards other than the RTX 5090, which stands alone in its class, have come down in price over the course of the year. Our data for late November showed that in-stock listings at MSRP for GPU models had increased substantially from 13 in June to 58 in late November. For all listings in stock, we saw an increase from 135 to 171 models on Newegg. Strictly for in-stock average price listings, we also previously aggregated data that showed a drawdown in GPU pricing, with the 9070 XT falling from $837 to $655 on average, the 5070 Ti falling from $951 to $821, the B580 falling from $343 to $264, and the RTX 5080 falling from $1,514 to $1,359. The only card in this table that went up on average was the one with the most VRAM and the one that has the least competitors, which is 0, and that's the RTX 5090. The 5090 is not only uncontested, but it's useful in AI, and it also is strapped with the highest VRAM capacity out of all of these cards, which means it'll be the most immediately sensitive to memory pricing changes. That GPU's price increased from $3,049 to $3,102 on average against a $2,000 MSRP advertised. Our charts from that piece also looked at the cheapest 4 in-stock models per GPU variation, then plotted the data for price over MSRP on average. Most cards were slightly below or were at MSRP for their cheapest 4 in stock, with the 5080 and 5090 above, with the 5090's 4 cheapest in stock models averaging $1,103 over MSRP, or an increase of about 55%. That's data that we pulled only a few weeks ago, and now, looking at what our own sources at SIs and AIB partners are saying, plus Benchlife's, plus the Bulbanton forum sources, it looks like NVIDIA could be cutting GPU supply just in time to kneecap the consumer price downtrend and benefit for consumers and keep it elevated for pricing. This allows NVIDIA to shift its focus and keep supply of both memory and GPU silicon in the enterprise and data center world, and now in the military-industrial complex, per Jensen Huang's new and disturbing obsession with AI applications for the military, which, again, for some reason are vilified, nobody knows why. Looking at PC part picker price trends, the bearer of the highest memory capacity, the RTX 5090, has actually started already to see price creep upwards again in just the last 2 weeks. The rest of the cards, fortunately, are still showing that slow downward trend, but we don't know if that's going to continue. Data center GPUs largely run on HBM, or high bandwidth memory, but the cost of a lot of different types of memory are directly tied to GPU utilization of its own memory supply, both HBM and not. That includes DRAM pricing for DRAM that you'd put in a motherboard as being directly tied to GPU utilization of memory supply. Completed video cards and GPUs cost not only the wafer area to make the graphics processor itself, but also the wafer area to make associated silicon components. That include VRAM, like HBM or GDDR memory, but also silicon often derived from TSMC wafers used to make interposers that HBM tends to sit on top of. Every GPU sold has memory attached to it. For now. I mean, they'd like to sell you a 0 gigabyte RTX 6060 Ti, but for now, they all have memory. Just for GPUs alone, a reported Morgan Stanley analysis posted on Twitter from February of this year suggested that NVIDIA would consume 77% of AI wafer allocation. The total AI wafer consumption was valued at up to $14.5 billion. NVIDIA's consumption increased from 51% in the prior year, with AMD, AWS, and Google declining in the 2025 estimate. NVIDIA is also now one of the largest consumers of memory supply just in general.
We work with every single memory vendor now. We have 3 different sources, 3 gigantic sources of really complicated memory.
The GPUs you're looking at right now use HBM, or high bandwidth memory. HBM has been used on consumer cards in the past sparingly, mostly in failures by AMD, but these days it's most commonly found on data center GPUs. The name gives away its higher bandwidth benefit. The value of HBM is obvious for tasks that are memory intensive, and particularly that are bandwidth intensive, like training for AI tasks. Memory is made using silicon wafers, just like the ones we saw in Intel's fab for its CPUs previously. Wafer supply is limited, largely due to the amount of machines available to actually process those wafers, and now that is more true than ever that OpenAI has claimed 40% of the world's entire memory supply for itself. As for what they'll use that supply for, other than further consolidating power and memory supply into data centers to then lease it back to you in some capacity, we assume that it'll be to power ChatGPT's erotica fan nonfiction, where all the corporate tech CEOs form a giant circle around consumers for their annual circle. Because wafers, or more specifically, wafer processing capabilities are finite, the wafer allocation for business enterprise is shared with the wafer allocation for consumer. They are one and the same before they get processed into something, but it's worse than just the fact that this is all shared with a group that can outbid you. Data centers typically use GPUs that utilize HBM, which can require more wafer area when considering all factors for the memory produced than with GDDR7. Now that is specifically factoring in things like yield losses. Gartner HBM forecast report author Shrish Pant, in an interview with Tech Target, provided context on HBM's die area cost. Quote, "You will need a much bigger die to produce a similar gigabyte of HBM chip," end quote. Citing Pant, the publication wrote, quote, "The larger die is needed due to the process of through silicon via," end quote, manufacturing, we'd assume. Citing Jim Handy, the general director and semiconductor analyst at Objective Analysis, Tech Target quoted Handy as saying, quote, "The wafer costs more and it produces less than half to have as many chips," end quote, comparing that to non-HBM solutions. Speaking to some of our own sources and technical analysis, we learned that you would need around 2.3 to 3x the DRAM die area for